Hi, this is Tom Reardon, math teacher from Ohio. We're answering the question, why TI-Nspire CX? This is a pre-calculus activity, or sometimes for Algebra 2, on conic section investigations and their definitions. The TI-Nspire CX handheld and software are now in color. Beautiful color. Why Nspire CX? It is a learning tool and a teaching tool. It is no longer just a graphing calculator. It has a touchpad and now in color. Students often have a difficult time understanding the definitions of the conic sections, parabola, ellipse, hyperbola. With TI-Nspire CX, students can verify these definitions for themselves. Watch. What we'll be doing can be done on the student handheld. We're just emulating it with this TI-Nspire CX Smart View emulator software. This is called Constructing Conic Sections. We'll click on to the next page. Here there'll be some directions on paper, but basically the student is asked to grab point D and observe what happens. And you'll notice that the distances F to P and P to D are changing, but they always seem to be equal. If you've watched the flight, or the path, I should say, of point P, it seems to be tracing out, and we would ask the students what, and hopefully they would say a parabola. And then we'd say, well, why don't we go ahead and construct that locus? So we'll go to Menu, Construction, and Locus. And we want to construct the locus of point P, click, as point D, click, moves. Press escape, and I'll grab point D and watch again. FP and PD are equal, and we do our tracing along a parabola. Remember the definition, the locus of coplanar points that are equidistant from a fixed point and a fixed line. So those are equal there. And we've got it color coordinated so that students can hopefully follow that a little bit better. I used to do this by hand with chalk and string on the board. It used to take many, many minutes, and I did it. Here the students doing it at his or her own pace. This is so much better. But wait, there's more. Here, the student is asked to grab point D again and watch what happens. We pull on the circle. You'll notice that the distances F to P and P to O are changing, but their sum, if you look in the upper left-hand corner, is always a constant 4.35. And if you also notice the path of point P, if you look at it, it seems to be tracing out an ellipse. So what we can go ahead and do again is to construct the locus of point P, click, as point D moves. And there we go, surprise, surprise, it is an ellipse. And if I grab point D, you can see that point P is following along that path. Recall that the definition is the locus of coplanar points such that the sum of the focal radii is a constant. In this case, 4.35 is that constant. But there's even more here. I mean, I used to do this with a piece of wood and 2 nails and some string or something, and it just, again, took me a long time. Here the student is doing the investigation. Now I can grab point F and watch what happens. Again, PF and PO change, but the sum doesn't change. It gets more and more like a circle, okay? And we start talking about eccentricity and different things. But now as I pull point F away from point O, from the other focal point, watch what happens. Yeah, that's really kind of an aha moment right there. No longer, when we're outside of the circle, do we have an ellipse. It actually turns into hyperbola. And I've had some students who don't really care too much about mathematics want to know what happened here. Finally, we'll look at this last one, and I think you're going to anticipate what's going to happen here. Grab point D, watch the flight or the path of point P. It may be kind of hard to see, but it is a hyperbola. The difference of the focal radii is a constant in this case. So again, we'll go ahead and construct that locus of point P as point D moves. And again, you can see that as I grab point D, P does go along the path of the hyperbola. F and O being focal points. Again, if I grab point F, you can see how the change in the hyperbola, and if I bring point F here, wow. Okay, so this is pretty amazing. To summarize, here we have the parabola, ellipse, hyperbola, all based on the definitions. I know of no other software that will allow the student to interact with this and come up with such amazing results. And hopefully the color coordination of the points and so on and the names will help the students understand as well. This concludes the video.